All right, well, we'll get started. Today's presentation in this workshop, it's called Running AI Models on the NVIDIA Jetson's CPU and GPU with Balena. I'm Alan Boris, a hardware hacker at Balena, and here is my contact information. If you should have any questions after this workshop, please feel free to get in touch with me. And also, if you have questions during this, please put them in the chat or just jump in and I will answer them as best I can. So before we get started, let me just do a quick story, some background about how I got started with Edge Impulse. Now, Mark Post, our developer advocate at Balena, about 2 years ago, he created this first project called socks, matching socks. And it was an interesting project. He calls it, his words, a stupid project. I thought it was really great, and it worked. So what could be better than that? But it basically detected whether socks were a matching pair. And it was actually the first Edge Impulse to run on a Linux OS, that Linux OS being Balena OS. And I'll talk more about Balena OS as we go on, and why we're using that here in this workshop. But this was a great introduction to Edge Impulse for me. And then I think it was a little while later after that, Mark and Mithan worked on this AI-powered bird watcher with Balena and Edge Impulse. And that was another really interesting project. And so that really piqued my interest in Edge Impulse. And then finally, last summer, I took the Coursera course on Introduction to Embedded ML using Edge Impulse. Really interesting course. I hope it's still available. It was free, and it's definitely worth taking. And in this particular video here, and you can see the link down here if you want to check it out, we had a show at Balena called the IoT Happy Hour. They're all archived on our YouTube channel. But basically, I took an Arduino Nano BLE 33 cents, and I attached it to my air conditioning, my central air conditioning system, and trained it on the different vibrations that it makes. And the idea was that I would do anomaly detection if my air conditioner starts shaking in a really strange way. I would know that maybe there's some maintenance. So it's kind of a predictive maintenance type of setup. So this is basically, and then I was hooked on Edge Impulse and love to use it anywhere that I can. And it was really impressive how much could be done with such a small device with such few resources on board. But so that's my introduction. That was how I got involved with Edge Impulse. Now, normally, my day job at Balena, we use single board computers, not microcontrollers, say such as the Raspberry Pi, x86 devices like NUCs, and NVIDIA Jetsons. And this right here, what you're looking at, is an NVIDIA Jetson device. And for those of you that aren't familiar with the Jetson, it's a very powerful, actually module, and the module is mounted under this heatsink here. And in order to use the module, it's usually put in a carrier board. The carrier board you see here is called the NVIDIA Jetson Developers Kit. And that's probably what most people use to get their project, what do we say, to actually build their project. Because after a while, you normally embed the NVIDIA Jetson module in an end user device, like a consumer device or a drone or anything that you want to have embedded AI in. So the Jetson Nano has 128 CUDA cores and 4 gigabytes of RAM. And the developer kit's only $99. At least it was when you could find it. I'm not sure what the situation is now. So just to summarize about the Jetson, I mean, many of you probably already know about it, but there's also a $49 version with the same amount of CUDA cores. And CUDA is just NVIDIA's library that keeps you from having to write low-level code to access the GPU function. So if you want to program your AI, it gives you a higher level language, and the power of the device is usually measured in CUDA cores for these NVIDIA devices. Now, I actually am using the 2 GB version, which was $50 when you could get them. And that's a pretty compelling price point for this kind of power. So what you're seeing today running on $50 hardware is pretty impressive. So that is the Jetson in a nutshell. And as we mentioned, if you have one, please bring your device, get it out of your closet now, and we'll have a chance to get it up and running on the the demo that we're going to do shortly. So normally, when people think of a Jetson, they think of running AI on the GPU because that's what it's optimized for. And you could certainly run Edge Impulse on the GPU, but we thought, let's run something really powerful on like a really powerful AI on the GPU that's CUDA enabled. And then since Edge Impulse is so awesome running on lower resource computers, let's run it on the CPU, and let's run both and not waste one cycle. Let's just burn down this NVIDIA Jetson. They already run hot, so we're gonna run something on the GPU, and then we're gonna have that data communicate with the CPU, and then we'll run Edge Impulse inferencing on the CPU. If we go to this next slide, you can see basically what I was talking about. We're going to run one program on GPU and another on CPU, both running locally on the device. Now, this kind of setup works really well when you have one device. You can flash the SD card and get everything up and running. But what if you have 10 devices or 100 or 1,000 or 10,000 devices? And they're all over the world. Well, you really can't go around to all of them and reflash the SD card. And what if you change your Edge Impulse model? Well, how are you going to get that model out to all your devices around the world? And that's where Balena comes in. That's why we're doing this on Balena. And you may ask, so what is Balena? And disclaimer, as you already know, I work for Balena, but I'm still going to give you the high-level intro, just in case you're not familiar with Balena. And if you look at where the arrow is pointing, this is a Balena product, actually. So you may not know the name Balena, the company, but you may know Balena Etcher. This is used to flash SD cards, usually with an OS, but it can be, let's see, I just want to make sure I have opened the proper chat here. Let's see. Yeah, so I see one person has answered that this is for burning images on a card, and that's true. This is Balena Etcher, and like I said, we have millions of people using this every month, and this is probably the product of Balena's that most people know about. This is an open source project from end to end. This is open source, and go to the next slide here, excuse me. And at a high level, Balena, other than Etcher, is a platform for device fleet management. It's also an operating system that's optimized for running Docker containers on embedded devices. It's open source from end to end, and it also includes a cloud dashboard to keep track of all your devices. And we'll see this in the demo. And this, just an idea, to give you an idea of the kind of Balena ecosystem. You have Balena OS, which is open source Linux operating system that's based on Yocto. And the interesting thing about Balena OS is, and we have Balena OS for about like 80 different types of devices, edge devices, single board computers. But the interesting thing is Balena OS only runs containers. It's as if it's a container operating system. Thrown everything else out, you can't run anything else on the host OS. But it will run containers. And then in order to manage your devices, you have balenaCloud and Open Balena. Open Balena is the is the free version, and balenaCloud is our premium paid version of the fleet management. But you can sign up for balenaCloud for free and get 10 fully featured devices for free that you can manage. So I would encourage people to experiment with balenaCloud, open balenas, if you want to run the whole show yourself. Now, in order to run the Docker containers on the edge, we have Balena Engine, which is part of Balena OS. And it is an open source container engine that is based on Docker Moby. And we already talked about Balena Etcher. And finally, Balena Fin is just our industrial strength Raspberry Pi, made for industrial and professional use cases. It takes all of the weaknesses of Raspberry Pi 3B+ and makes them more hardened for like factory use or so forth at a, at a really good price point. It's, as far as like storage, power, networking, all improved over a stock Raspberry Pi 3. And this is just a quick kind of block diagram of a typical Balena device. You have the OS, the engine is part of the OS. It's made for running containers. You have users containers, and you can have as many containers as your device can handle as far as CPU and memory. But we include one container on every device by default called the device supervisor. And the supervisor is kind of the, it's like the interface between the cloud management and the OS, and it allows you to push updates to your code. It allows you to update the OS all remotely. The supervisor is constantly looking to see if you've pushed new updates to your device. And next is, how do we run AI models on the NVIDIA Jetson CPU and GPU with Balena? So this is basically just a small review of how we're going to do what you're going to see today. On the GPU, we're going to run something called Open Data Cam. It's an open source tool to quantify the world, and I'll give you links to that. You could run that totally independently. It just requires a Jetson GPU with CUDA. It is an object detection algorithm that counts and tracks moving objects. And we'll see this live in a moment. The interesting thing about Open Data Cam is it outputs data and not images. It's very privacy focused. So when you're recording with Open Data Cam, you're just recording data on what it sees, but you're not recording videos and you're not recording images. So that's great from a privacy standpoint, and also great because it doesn't fill up the device's SD card or memory with a bunch of big video files. And it runs fully on the edge. You don't need a cloud connection in order to run Open Data Cam because it's using the GPU. And all of the data that Open Data Cam records about the objects that it finds are available via a local API, which is what we're going to use to pull that data off. Here is a link, or this is an image of the GitHub repo, but you can see the link there to our version of Open Data Cam. So we forked Open Data Cam, and then we made it more Balena friendly by containerizing it. So it's really easy to deploy because we put a deploy with Balena button on this repo. So you can really just push that button and it'll take you through the process of deploying it, which is actually much easier than the instructions to deploy it on Open Data Cam's own repo, which it's a great repo, but they have many different ways to deploy it, and it can get complicated. And in fact, they're so happy with the Balena way, they actually put a button on their repo for deploying with Balena, so it's an option as well. So this is just a little more info about Open Data Cam and how we're pushing that data to Edge Impulse. What we're going to do is I wrote a little Python script to record 60-second chunks of data from Edge Impulse of traffic outside my window here. Hopefully we'll have some traffic, but we're going to count the cars. And through the Open Data Cam API, we're going to feed this data to an Edge Impulse model that's running on the CPU of the device. And we're going to get an inference on that data telling us how good or bad the traffic is and whether it's at a standstill. Because, what if we couldn't actually watch the traffic ourselves? We want to know what the traffic level is. So we're going to use the Edge Impulse model to do that. And then what I'm also going to show you is what if we also wanted to use those inferences to further train our model. We're going to allow us to automatically upload that information back up and relabel it if necessary to improve our model. And then we could retrain the model and push that new model back out to all our devices. And that's all using, the balenaCloud platform to do that, which is part of the point of today's workshop. And this is just a high-level overview, just in case you need a little more clarity on what we're doing. We're going to send video to a container that's running OpenDataCam on the GPU. We're going to pull that data from the API and send it to a container that's running on the GPU. And we're going to do inferences with Python using an edge impulse model. So I think that explains it. If people want to get their device ready, get it, get your SD card, whatever you need. Make sure you have your power cord. I highly recommend using the 5-volt 4-amp external for this, because we're going to pull a lot of power today. We're going to burn down our Jetsons because we're going to be using just about every cycle that we can. I can't quite point my camera over here, but I have a massive fan on top of my heat sink because they get really hot to the touch.
So let's do this. I have my power supply, which I think will work. I have my Jetson. Hopefully some folks watching also have a Jetson. I've got a USB webcam. I did not bring a Raspberry Pi cam, but I think this
better.
Good.
That's good. Yes.
Okay. I have SD cards. You know that we need those.
We need those.
And I have Etcher. So I think I'm ready.
You sound ready. So what I thought I would do is just take a few minutes to show what we're actually going to do. And then I'll go through how you would actually get your device to do what we're going to see. So you can see basically just the overview of this project, and then we'll actually we can walk you through it, David, and others can follow along. So let me just at a high level show you what we're going to be doing today. This is the repo for it. You don't necessarily need that now, but if we go to our project page, this is these are the devices that we actually have running. This is the balenaCloud dashboard. And if we had 10,000 devices, you would see them all here. But right now we only have 2. And Mark's actually went offline recently, and he's on an airplane now, so I can't get him to turn his on. But that's okay. I have mine on right now. So that's all that matters for us right here. Another cool thing is you can click on this map and see where all your devices are. Hopefully we'll get a few more on here today. Mine's here on the east coast of the US, and Mark's is in Spain, but offline. And if I go into my device, you can see here that you can SSH into it. You can see all the containers that are running on here. You can do all this remotely, push code, release, update the OS. But I am going to just grab the local IP address of this, and I'm going to open it in a browser to port 8080. And boy, look at that. We got a lot of cars out there today.
Oh, we sure do. You've got some traffic.
And just so people know how I'm doing this, I actually took a video camera, not like an IP camera. I took a video camera and I'm feeding it into an encoder board and then converting that to an RTSP stream that's going in here. I find that works best because those video cameras with an HDMI output allow you to zoom and change the focal length, and it's really, and they're really clear pictures. So that works great, but a webcam works fine too. I'll show you how you can switch the input on OpenDataCam. But we're going to go into this counter screen, and what you're seeing here is I've drawn lines on the screen. You can draw these lines, and then OpenDataCam will actually count the cars that go through the lines when you're in recording mode, and then that data becomes available in an API. For this demo, I've just changed it so that we're only going to count cars that are going from right to left. because otherwise it would get kind of confused. And you can see the bounding boxes change colors as it goes through each line. So let's actually just do a run real quick. I'm going to go back to this device. I'm going to SSH into the Edge Impulse container. And normally you would want this to start automatically so you wouldn't have to SSH in and run it, but I wanted a little more control today over this demo. So I don't have this starting up automatically, but you could put as the startup command Python 3 runner.py, and let's run it. Is this where we have to do our, what do you call it, David, for demos?
Well, I would say this is say a prayer to the demo gods.
Yeah, I think so, especially.
This is a bold move trying to run this live.
It certainly is.
Let's say our prayers.
All right, here we go. Okay, so this is good. So it has found the 2 lines through the API. It's communicating with the other container, and it started recording in OpenDataCam, and OpenDataCam responded, okay, which is a good thing. I'm going to move this slightly. So if we go into OpenDataCam, you can see it's in recording mode. Now, the other part of this demo is let's hope a car goes from right to left through both of these lines. We're recording 60-second increments. It's 1:43 in the afternoon here, so there should be some traffic, but it looks like we got 1 million
cars a moment ago.
I know. It all depends on the traffic light
everybody?
off screen here that you can't see that backs up the traffic.
Oh, well, we'll just wait for a green light and they'll all come flowing by.
We have 15 seconds. Let's see what's going on here. We might have gotten 1.
Yeah, but he went. Wait, were we hoping for left to right or right to left?
It did find 1 car journey. So let's look at this for a second. So this again is a Python script that I wrote. It's available in that repository, which we'll make available to anybody. And you could definitely adapt this for your own needs. But if you look at what we've done here, so OpenDataCam on the GPU sent this data to Edge Impulse, which is 1 car, and it took 965 milliseconds to go through the 2 lines. And then on the device, on the device, Edge Impulse loaded locally this particular model and ran a classification on it and said, hey, that looks like light traffic to me. And then we're just getting some kind of, like developer feedback here on the inferencing. But the interesting thing to note is that this is all done locally and through the API, and that this Python script is using a model that I specified in the device variables for this device. If we go to this model called traffic 22V, you can go here to keys, and each one of these, and David, correct me if I get any of this wrong, but each one of these has a key that's specific to this particular project. This one is for pulling down the model, and this one's for pushing data back up to it. And if you go back to our device, and we have these device variables, you can actually, I've specified in here for this device which project in Edge Impulse that this Python script should be using. And if we go to this line right here in this script that runs every time the container starts, we're just going to pull down that model, which means if we change the model and save it, we'll get the latest version of it every time we restart this container. And if we go back here, you can see that, I've started this loop, and here, this one found 10 car journeys, and it still thought that it was light. So I think that one, we might need to talk about, sending these samples back up with a different label to help retrain my, my model on Edge Impulse. Let me just say though that my Edge Impulse, this model is for demo purposes only. It is not a good model, okay? We need to do a lot of work on this model, and it's probably not even the right type, but the point of today's demonstration is the workflow and communication and running the 2 on on two different aspects of the device, not to make a great edge impulse model. I'm sure there's plenty of other demos and workshops for that. But it actually works better than I thought it would. But let's go make one more change here to this device. And we're going to change one thing here. We're going to go back to this variable. And these variables are very powerful because it allows you to change what your device is doing. And say this device was sitting on the other side of the world and I couldn't actually reach it physically. So I'm going to change this particular variable, upload data files. I'm going to change it to, oops, I didn't actually change it to anything. Let me change it to 1. Save here. And we're going to go back here and the device is going to stop. I'm going to actually manually stop the recording just because I changed this without, right in the middle. What it does is it restarts the container. So if we watch here, it's restarting the Edge Impulse container. And I think it went by too fast, but it downloaded the model again. We get a lot of, yep, there we go. So
There it is, yeah.
it downloaded the Edge Impulse model again because I restarted the container when I changed that variable. And now if we SSH back into that container and do the runner again, this time, every time it runs an inference on the CPU with Edge Impulse, it's going to give us the option to upload that sample data back up to Edge Impulse and relabel it. So let's try that.
Which is interesting because then you can start the process of fine-tuning that model. So like you said a moment ago, maybe your model is not the best at the moment,
Right.
But with additional feedback loop and more images and data going up, then you can start to really improve, rebuild, retrain, and improve the accuracy. So you can come away with a pretty good model towards the end. While that's going, oh wait, did you already start a new run?
Oh, sorry, I started a new run, but it's okay.
Yep.
It'll pause when it gets to
when it gets to the end. I was going to say we do have a couple of questions. AB is asking, how does the model determine if traffic is light or busy? Is that a threshold that you had set somewhere then, Alan?
I did, yeah. I set a threshold for the number of cars, but we have, and that's a simple select case on the number of cars that goes by.
Gotcha.
But we also add in the average number of milliseconds it takes to go from one line to the other.
Oh.
And there's also this situation of standstill. That's where it gets interesting and why we're using AI, because the traffic can get backed up and the car count can go down, but the number of milliseconds it takes goes up.
To get from one side to the other. Mm-hmm.
So you can't just go on that. And I will admit that, maybe you could possibly get by without AI for this. That's not really the point of the demo. The point is how it all works together. You could do this with, a dozen other different types of things. One thing I'll also mention, though, is that we are also sending the hour of the day along with this data. And we hope to do AI to predict traffic based on hour of day, perhaps temperature. There's all these other parameters, whatever makes sense. So this is just the very start of this idea, but at least you get to see the workflow. And yeah, as far as to answer, it looks like a question about Open Data Cam. This is using YOLO and Darknet, and it's not custom. This container is, I think it's stock YOLO. And if you look at the Open Data Cam repo, they have all that info on there about what this is using. But let's just go back here for 1 second and see what happened. This is what happened, before it made this classification. But it has this new line here, preparing to upload data file to Edge Impulse. And this would be the data file right here. So 3 cars, average 1100 milliseconds. And since it thought that this was light, it's saying, do I want to type a label, or do I want to just use light? If I hit enter here, it's going to upload it back as light. But just to prove the point, I'm going to change this to moderate. And I'm going to hit enter. And it says upload file to Edge Impulse, moderate 3E1Q. So let's make sure that happens. So we go to Edge Impulse, data acquisition, and yep, there it is, moderate 3E1Q. So we can keep uploading these and changing the labels to be more, accurate. And then, we can retrain this and save it, save the retrained model. And then if we just go back to our container here and restart the container, it's going to pull down the new one, the new model that's retrained and hopefully better. And it's just going to continue to inference, but it's going to use that updated model. And you'll notice when we do that, Open Datacam doesn't skip a beat. This is going to keep running because the only service that we're restarting is the Edge Impulse one. And one other thing I'll mention, and we can demo this later if we want to, but if you go back to device variables, we could change this API key to a different model. Say I have a model here, maybe I'm not so happy with 22V. I have this super duper 26A that's so much better.
That's a way better one. 26A is much better than 22V.
So all I need to do is copy and change that API key, and it's going to pull down 26A and start doing inferencing on that. And let me just mention, last thing here is this fleet value. If I have 1,000 devices, I could just change it here and it'll change it for all the devices. So they'll just keep running, but they'll restart that one container and pull down whichever Edge Impulse model that I specify here. And we could even split them. We could have, say, a like staging model that we're uploading the samples to, and a production one that we're actually running the inferences on. So you could split these, and it gets very interesting, the possibilities. But anyway, that's the overview of this demo. And now let's, I guess, help David join it, or anyone else.
We're gonna try, but I wanted to make a quick note. AB and Nico are in chat and says it reminds of a good old balena happy hour, IoT happy hour, which is funny. Excellent. It really truly does. And that was one of the things that again I missed by joining late, but I wanted to say how happy I was to be on a live stream and a webinar with you again, Alan, because I really enjoy these projects that you put together. And I see the light behind you, the LED buzzer is there, and I had to laugh when I saw the street because I knew exactly where your camera was placed. So I'm super happy and super excited. So
thank you.
So let's get this Jetson going. We're gonna try. I'll say my prayers to the demo gods, and I'm a little bit rusty, Alan. I might need a little bit of guidance, but I'm going to try my best here. So what's the first thing I need to do?
Okay, let's see. So I guess that you want to run it and build it yourself. You can go to the repo, and you could simply deploy with Balena if you'd like to do that.
I think I'd rather join your fleet.
Okay,
we can give that a try.
That would be awesome. So I will just add you right as a member here. Okay, and I just need your
that's
username.
Easy. That is David _ Tischler 1.
Look good?
Looks good.
Okay. All right, and we can add anybody else. So what you'll need to do is sign up for a balenaCloud account, even if you were to use this deploy with Balena button. If you hit this button, and if you want to do this later after the workshop, if you hit this button, it will actually take you into balenaCloud. It'll ask you to sign up if you haven't. It's totally free. You get 10 fully functioning devices that you can manage. And then it'll walk you through building and creating the actual fleet and downloading an OS that's associated with that fleet. But as far as what David's doing, I can show it here David, but I don't know if you want to if you want to share your screen and go through the process. But once you're here and you have access to this, you would just click Add Device. And this is, gives you really simple directions to add your device. Once your device is added in, you're going to just download a version of the OS that's made for this particular device or whichever device you choose. You see here, you could choose a 4 GB version or even a TX2 if you have one. And you can actually even set your Wi-Fi password here if you want.
I'm going to have to attempt Ethernet because I'm in a hotel, so I'm at the Imagine event. We had in person yesterday.
Nice.
So I'm actually joining from Mountain View, and I'm in a hotel, which then has an authentication portal to deal with. So I'm going to attempt Ethernet. But I'm on the same screen as you. I'm looking at the same thing. I chose Jetson Nano SD card. I'm going to choose, the default version is 2.103.2. And I'll leave it on development. And I'm just going to leave Ethernet only since it's the only thing I've got. And I'm going to, at the bottom, click, I think I'm actually going to download Balena OS. You can click Flash, which will automatically pop at your, if you've got it, but I might want this image again later. So I'm downloading now. It's coming down and 186 megs, and it is done. Looks like my Wi-Fi is pretty quick in here. Okay, I've got the image.
Okay, and just to reiterate, what the image is the OS and an association to this project, which means when the device gets powered up, and gets online, it'll pull this project down and just start running it. So let's just mention one other thing here, though, David.
Okay.
I don't know if you have this. Depending on your version of Jetpack that you may have already flashed onto your Jetson device, you may have to use this utility Jetson Flash instead of Etcher. And this is a very temporary workaround, but because of the way they've evolved Jetpack, there's some current incompatibilities with Etcher, just with the way that they partition it. So I don't know if your Jetson Nano maybe has the older, let me see which, I wrote down which version of Jetpack it is. I believe it's 32.4.4. Do you want to try it?
I'll give it a try.
Okay.
Okay, I'm going to give it a whirl. Or
you could just, you could try this. It's not, it's not that difficult to do this.
I'll have to spin up a VM though. I would need a Linux box then. I
think this will work on Windows.
I'm just trying to think, what was the last thing that I ran on this exact Nano? So we're going to find out. It's okay. No worries. We're going to find out.
Again, this is a temporary thing. The fact that you have to use the Jetson Flash tool that will be integrated into Etcher. But, they keep throwing some curveballs with the Jetpacks. But
that's
not,
okay.
not a criticism, just, keeping up. It's something that needs to be done. So,
yeah. Okay, so I am going to launch Etcher. And Etcher is loaded. Flash from file. I'm on the exact same screen that you showed off earlier in your slide deck. And navigating to my downloads. And here is the file that I just downloaded a moment ago. balenaCloud Open Data Cam EI.
So I'm going to show that too. So you did SD card, production, you did development.
I did development, but yeah.
Okay, and then I'm going to click Flash, and it's going to allow me to just open Balena Etcher. It's going to download the image, like David said.
Yeah, mine came down pretty quickly, and mine is starting to flash. I am one step ahead of you.
So if you try to flash and you don't have an SD card in, you're going to get this, which is good
Yep.
because you don't want to flash.
No, you don't want to
system
flash your
drive.
laptop.
So let me stick an SD card in here just so I can show where David is. I'm putting an SD card in my machine. There it shows up. And let's see, now we can select it.
Yeah, that's what I just did. My flash is
Flash.
completing.
And we are flashing.
And mine says done. I am still just a moment ahead of you. So here it is, right out of the laptop, flashed and ready to go. Now,
I'm pretending to follow along here.
You're pretending to follow.
I have my
okay.
same Jetson. I have a fancy case for my Jetson.
You have a fancy case on yours. Now, these are interesting. You have to make note of where the SD card slot is on these. I don't know how well my camera is going to show it, but it is underneath. So the heat sink is on top of the SOM, like you talked about earlier. The module sits in a small carrier on the carrier board, the base board. And in between the carrier board and the SOM, on the underside of the SOM is where the SD card goes. You can just see that blue stripe on there. That's about where you're aiming for. And if you turn, will click into place.
On the back,
yeah.
And this one has a little hole for it, but yeah, it's just under the card. And you put in the SD card upside down, right?
Yes, correct. Yep.
You just slide it in there and click it in.
All right. So now I've got next up power and Ethernet. Let's get those in. Again, not totally sure that this is going to work, but that's all right. It's still a good learning exercise. And we're talking through the process. So for anyone following along at home, you may have more luck than me, but that's because I'm in a hotel. All right. I've got.
So we'll know it's success if David's device shows up in this list.
Yeah, that's.
We'll know we have success.
Okay, so the Jetson is on my desk right here. Power, Ethernet, USB, camera. And let me make sure that I have enough power here because I should have.
And I can show off a little bit here. I have this. Here's one of the recommended power adapters. This is a beefy 5-volt 4 amp with one of these connectors on it. And I could actually pick up, David, if you want me to pick up where, at any point I can follow along here.
You might have to. Interestingly enough, I don't know if these cables will reach, but let's see if I can get it on screen. I cannot get it to boot and watch this.
No.
You'll be able to see exactly why, and we can talk through what is happening. It's fine. It's a good lesson. Okay. When let me see if I can do this backwards. We should see there. You can see the green LED. That's powered on. It is now attempting to boot, and then there goes the green LED. It's not drawing enough current through this. And this is a 5-volt 3 amp adapter, so I should be pushing about 15 watts, and it's not enough. Now let me look into my bag of goodies and see if I've got anything stronger. I came prepared, but I don't know if I'm going to have anything stronger than that. So you may have to take it over. Let's try this.
I'm going to flash again.
Yep.
And I'm going to do exactly follow with what David did. You'll also notice here that during the flashing process on Etcher, we display various projects that open source projects. These are not paid advertisements, but open source projects that that are listed here. And if you click on Get Started, it'll take you to our hub where we list a lot of different projects that you could try. And I believe some of them, I think the Birdwatcher one is on there as well for people that want to try that.
I saw it the other day.
Yep. So I'm going to pick up here and follow along in case David runs into a complete stop. I'm going to plug in this beefy power supply. I get this on Adafruit. I basically have a standing order with them every month. I get so many parts from them.
That's where I ordered mine. I have that exact same unit. And I have several of them, but they are at home in Phoenix and I am in California.
Right.
Nope, I cannot get this one to power on. Let me try without USB camera or Ethernet hooked up just to get through the boot process. The boot process itself actually, and this is typical on many devices, to be honest, not only this Jetson. During the boot process, you do some CPU saturation and you draw basically, a high current. Once the device gets through the boot process and the core's throttled down, you don't always reach that peak, again, unless you're at 100% maxed out CPU cores. But if I have a strange feeling, if I was able to overcome and get through just the boot, I would be okay. But that's all right. Let me try one last adapter and see if this one works. I can also try straight from the laptop itself. All right. Well, you're making good progress. I'm going to just keep attempting here.
I'm just going to continue with this for a moment, and then you let me know if I need to continue with this. I have it in the same spot as you, ready to plug it in and show what the next step would be.
I think this is going to be about my last attempt right here. I'm running out of options. Okay.
I'm going to label some more data here and keep running this. Let's see. Traffic is a little light right now, so maybe we'll get some light samples out this window.
No, I cannot. All right, you're gonna have to proceed.
No problem. All right, so let me go back to our dashboard, and this is just going to keep running in the background, but we're going to go to our devices, and so I've put the SD card in this device, just another Jetson, and now I'm going to power it up. You know what? Actually, I'm going to use Ethernet as well. Glad that you were, because we don't want any surprises here during a demo. So I'm going to plug the Ethernet in. Handily had an Ethernet cord just happened to be sitting here.
Well, that's convenient.
And powering it in. So let's see. And this one, David, this one has a fancy power button on it. So
that's a nice feature. I don't have that.
The only thing this doesn't have is an LED visible from the outside. That's the one shortcoming of this particular case. But I can see on the inside, I see the LED has lit up. So there's a future project for me to add an LED to this case.
Nothing a drill can't solve.
And I have my camera connector sticking out because it's a pain to open this case up every time you want to connect a camera to this. So let's see. Now, if all is working well, we should see this come online within another minute or so. We should see it in here. Let's hope. Sometimes it takes a minute. Now, unless, of course, I also flashed this with the newer jetpack and didn't realize it.
Yeah.
I may have been testing that for somebody. And
so while we're waiting on that one, let me head back over to our Q&A. We had a few. I see AB said to use a hotspot. That's actually very good advice, but because a hotspot isn't going to help me if I don't have enough power. But let me see here. So Nico had mentioned that the button will take the normal Open Data Cam project, not the special one of Alan. But Alan, your button was in your repo, so that should, in fact, be valid.
It should be this repo right here, this Open Data Cam-EI in mine. Let's see if we click, actually, we can check this and see it should be set. It is set here. So that should be the right one.
Yeah, so it should come from yours. Yeah. So I think we're good there, Nico. Now I see AB had then mentioned, does it not come with a full-fledged image? It does come with a full-fledged image. The OS, what specifically changed, and I think Nico is familiar with this and may have, in fact, commented. He said, NVIDIA did a lot of changes in the current Jetpack. I won't say that they broke, that is not a valid statement, but they changed the way in which the stage 1 bootloader, they use core boot, if I remember correctly, not U-boot. And this gets really, really down in the weeds, and Alan knows these battles quite well, but the way in which it boots before it ever gets to Linux or the kernel or Jetpack, or they call the OS. They use a derivative of Ubuntu. Because they made the changes so early in the boot process, we can never even get to a point where the device tree is low, U-boot, or well, I guess core boot, and the device tree is loaded and the kernel comes up and so on and so forth. We never even make it that far. So, they are certainly entitled to, produce whatever software that they want to produce. But then, Balena then has to adapt. So it's not exactly helpful that they changed the stage 1 boot protocols, but it is what it is. So Nico's correct. So AB, yeah, it's a full image. It just won't reach the full image. Gordon had some questions here. Do they have a version of the boot program that doesn't run the high current startup? So it's not so much a difference in the boot program. Their version can in fact get away with loading on micro USB. It's a 10 watt, it's a 5 volt 2 amp power supply. I think that they recommend. It could even be a 5 volt 2.5 that they recommend. You'd have to look at their documentation. But I know that once we're going to load these GPU cores and CPU cores at the same time, we're going to draw more than we'll go across that micro USB port. There is a jumper, a tiny little jumper that is on the board by the power supply, by the barrel jack power supply that you have to flip depending upon which power input you want to use. Let me see here. Ogden had, do you guys have any advice on powering nanos in the wild from solar, for example? Well, these are, it's going to take a big panel and a big battery. Jetsons are not as power efficient as something obviously like a microcontroller, or if we're sticking in the Linux world, call it perhaps a Raspberry Pi Zero or something like that, which is, pretty low wattage. It could theoretically be done, but you'd have to go calculate your power consumption and then accommodate for what size solar panel plus battery are you going to need. So you'd have some math to do there. And is it possible to run existing models using a Raspberry Pi, for example? So in this particular case, Alan, I'm going to turn it over to you to answer, but I think that this is a CUDA application that we're using. Open Data Cam is going to require a Jetson. Other edge AI projects doing other types of inferencing could absolutely run on a Raspberry Pi, but correct me here, Alan, I think this project is going to need Jetson, right?
Yeah, that's correct. As you can see, it's really doing a lot in real time. And this is something that, you know, a Raspberry Pi, even, you know, with even a 4 with its GPU just wouldn't be able to handle
Yeah.
this. This is very, very CUDA intensive. You see what it's doing here.
Yeah. And if it's
So,
specifically written for CUDA cores, the Pi just doesn't have them. I mean, you could certainly attempt to run it in software, but if there is an application that physically 100% requires CUDA, you are looking at NVIDIA hardware. All right.
And I did update the repo so that the deploy with Balena button does point to the proper.
Good catch.
So thank you for pointing that out.
All right. So I think we made it through all of them. If you want to continue on, Alan, I'm watching.
Okay. Well, it looks like I may have run into the boot problem as well.
You got the same boot problem as well.
Yes,
Well, that's okay.
But I mean, if we had more time, I would do the Jetson Flash. It's not that it's burdensome or anything like that. I just don't think it would be interesting to go through that. But it's very self-explanatory and easy. You really just follow. If you go to these three, it's really these three things right here. You clone this, run the install, make sure it sees your device, and then you just flash it and just follow these instructions here. If you do the flashing, and again, this is instead of Etcher and just for Jetsons and just temporarily. Hopefully very soon you could just do this through Etcher the normal way. But I'll just mention that if you get to this point, for balena.img, you substitute the name of the file that you downloaded from add device, or when you hit the deploy with Balena, you're going to download that image, put that name here, and then when it says -m device type, for the device type, you're just going to choose from this list whichever device corresponds to the one you're doing. And most people, I think it'll be the Jetson Nano QSPI SD or the Jetson Nano 2 GB dev kit.
Yep.
My dev kit does have the old boot. So, I mean, if we really want to go through that, I could just re-image that if we'd like to go through that whole process. So I'll leave that up to you, David, whatever you think.
No, you know, I think that we've talked through what the process is to bring a device online. It's actually really simple. I mean, I clicked the button to download the OS, flash the image, and assuming proper power and connectivity, the device is going to just simply join the fleet. Now, when that happens, what you would have seen would have been my device, my Jetson Nano. On your screen, you had two of them. You had Alan's and you had Mark's. You would have seen mine appear magically, and you would have seen David's, and you would have had a third device there. Mm-hmm. At that point, the device has checked in. It has joined the fleet, but it doesn't have its containers yet. That's where what you spoke about, the supervisor is going to say to the device, okay, this is great. We are a part of the fleet, but the other two devices have, did you have 4 containers in this application, I think? If you click on one of those, did you have 5 containers? Let's take a look here. 4. Yep, Audio, EI, MongoDB, and OpenDataCam. Well, so my device is going to come online and it's going to say, well, I have 0 containers. I'm supposed to have those 4 containers. And that's where the balenaCloud orchestration will say, all right, here are those 4 containers. Now, obviously, underneath the hood and in the background, those containers have, you know, checksums and hashes, and they're coming from the registry. But the device is then going to start downloading those containers. And as I look at those, if I remember correctly on this project, that's a couple gigs worth of containers. So AB, I'm thinking back to your comment about my mobile hotspot. I'm thinking, you know, in retrospect, probably good I didn't go that route, because I would have burned a few gigs of data on my phone. But
pretty big.
5.2, bigger than I remember. So, but point being then is that my Nano right here, who's not doing a whole lot at the moment, but he would check in, he would join the fleet, you would see him appear, and he would begin downloading those 5.2, 1.1, yeah, 6.5 gigs worth of containers. And then he will be running the exact same as the one that you have live there and are showing. So it's fine. You know, we've talked through the process and what would occur. I don't see any need for you to go and reflash your own device, Alan. I think the more interesting use of our remaining time is to obviously address any questions, but then also if you have more that you want to show off, I don't know what your if you wanted to explore what the data looks like that is coming off of it, or if you had other tidbits you wanted to show.
Sure. Yeah, let's take a quick look at the data. We just mentioned that this is a very large project. I mean,
yeah,
most edge projects I would say are a lot smaller, but when you start dealing with CUDA and all of the libraries and dependencies, it tends to get large. I'll just say that, you know, when you make changes to this, we do that kind of delta update where if you were to push changes out, we would only push out what's changed. So if you are on a limited bandwidth or a data plan of some kind, it'll only push the updates. But since David's device doesn't have anything yet, it's starting from scratch, it would initially push out all 6.5 or whatever gigabytes here. But let's go back to that device and go back here to Open Datacam EI. And yeah, unfortunately, yeah, my device hasn't shown up here because I really thought mine was not flashed that way. I can't remember ever having flashed a newer version of Jetpack on there, but I probably did just to prove the point that it doesn't work and then forgot about it. So.
I've used that Jetson Flash utility. It works fine. I have done it. In fact, I think I did it helping Nico troubleshoot way back in the day, more like probably like a year ago, but we did some version testing. That repo will work.
Yeah. So let's just change the model real quick here. We've been inferencing and uploading to Alan Traffic 22V. So I'm going to I'm not going to stop anything. Just midstream, I'm going to go to this super duper Edge Impulse project 26A, which has much better model, and I'm going to update all the devices in the fleet. We can go here and we can give it a fleet value. So I'm actually not going to update the whole fleet, but you could say for this change that I'm making right now, you could say change everything in the fleet to this. And let's take the HMAC key as well here for this particular project. And we're going to do it here. Save. And now if we go back here, you notice it's restarting everything. Don't worry about the red audio errors. We have no audio on this device, so that's to be expected. And here we go. It says it's downloaded the new model. And we got our prompt back because this container had just restarted, so it disconnects while it's restarting. And if we look here, we have the model. Now, every file that we saved that we didn't upload has been wiped away from this particular folder, but you can have persistent folders on the device. So even though the container, when the containers restart, they go back to their initial state, which means anything that you may have saved locally goes away, and that's standard container behavior. But you can specify a particular drive that keeps the data persistent. And actually the configuration for Open Datacam is stored on such a drive. So if we go back here, this is continuing to run and our counters are still here. That was saved to a persistent part of the device. So we don't have to change any of that. So the idea here is if this was running out in some country somewhere that we didn't have access to, this just keeps running. The only thing that restarted was our Edge Impulse container. And if we had set this as the startup, Python 3 runner.py, it would just start up again, but theoretically, it should be using the new model because, every time the container restarts, it pulls down the model that's specified in the API key, which is a device variable, which I just changed for all the devices. So let's see what happens when it goes to inferencing. It should inference on the new one. Remember, the old one was 22V. We should be at 26. We should be using model 26A now and getting much better inferencing on our super model. And let's see, we should have sufficient traffic. Oh yeah, there's some great stuff going on out there right now. Luckily, they didn't close the road today.
No, the light must have changed. It's a green light. Look at them all going.
So I would call this heavy. If we don't get a heavy, we should definitely relabel this as heavy traffic.
Guy needs to paint his fender. This is fun.
Yeah, it's fun to see outside my window. I mean, I just lucked out that, that I get this, that I have this outside. Oh yeah, definitely. We need to relabel this. But more importantly, look, it is using 26A because we pushed that model out to all of our devices. So let's relabel this as heavy and hit enter. And it says that it uploaded the file to Edge Impulse, heavy 3E1S. Let's make sure it uploaded it to 26A. And there we go, heavy 3E1S. And that was just a moment ago. So that's good. So now, we would, if we run this loop enough and keep uploading relabeled data, we would just retrain this model. And I'm not even going to go into the classifier because I don't want to offend at how bad this model is right now.
That's all right. It's not the point. It's okay.
That's not the point.
Nope.
But we will get better. And we retrain it, we save it, and then restart our container, and we'll get the latest and greatest model from here.
Yeah, that's really good stuff.
That's really the main point of everything here, I think. But if you have anything else or any questions, David, I think.
I do not. I mean, it's incredible how you have built the AB had made a comment in the questions or in the Q&A earlier about it's a good ML ops flow, and it really is, because what you've done is created a feedback loop to bring new data back from the edge device, retrain, improve the model, then redeploy, which is one of the things that people forget about. In the Edge Impulse world, you need a data set, and customers and users will upload their data, will label their data, will then build a model, go through the training cycles, the model comes out, it's generated, and they'll deploy it to the device and then ship the device out into the field, and that's wonderful. But what you're demonstrating here is the ability to continually improve the model then. And that's where ML ops, there's some opportunities there. There are other solutions out there, and they all have pros and cons, but you've shown a really good way to bring data back, make your device or make your model better, and then redeploy, which makes your device smarter. So that's really, really interesting. And that's one of the things that I like about the Jetsons and the Raspberry Pis and the Linux OTA world, whether it's Balena or, other solutions exist. But In the microcontroller world, that's more difficult. So this comes back full circle to the conversation about, how much solar panel or battery do you need to run a Jetson out in the wild? And you get into this situation where it's tough to differentiate when you're just using the word edge AI, but there's just different levels of application requirements. Look at what you're doing, which this live video inferencing, and I'm sure that's what 720p or even full 1080, whatever the camera is. Okay, a microcontroller is not going to do this at. You're probably 20 to 30 frames per second there, and that's only a nano. A Xavier is going to perform even better, but a microcontroller is not going to do that. So you have to then start to think about your thermal and power requirements versus your application. That Jeep just flew by. An ESP32 is not going to be able to do this type of work. So you have to consider what is the workload that you're trying to run, and if it's the extreme edge and you want to use an MCU that's that can run on a solar panel and a battery. That could run on just a battery maybe for a year or two, depends on what it's doing. But the use case that you're showing, it requires a higher performing device. And that's where you get into the Jetsons, the Toradex, the other, bigger edge devices. But I hate I hate saying edge AI because there's different flavors of edge AI. Sure. I know you've got an Arduino Nano 33. That could, that's not going to run this workload, but it can do edge AI. It's just in a different way.
It could run the one we're running on the CPU. You could offload that, but not this.
Yeah. So it's good. It's an interesting analysis. At the end of the day, I would have liked to have seen my device join your fleet, but it's fine. We can imagine that you would go from having 2 devices to 3 devices. And like we talked about, my Jetson would download those containers that you've built. And that's the beauty and the magic of fleet management and orchestration. And we didn't get there, and that's fine. But this, going through these examples, these exercises are still very valuable.
Yeah, and I think there might have also been one open question here about the best way to push really big models out to the field.
Let me see. I didn't see that roll in. Nico, you want to take that one, Alan?
Yeah, sure. One of the things that we support is preloading, where you could preload all the big stuff before you ship it out, and then just send updates, which hopefully it would just send the changes since you preloaded the SD card. There's more information about that if you're interested in just searching balena preload, and you can see all of the multitude of options for preloading.
Yeah, I'll grab the document. I'll grab the documentation link. And if you want to talk a little bit more about that, Alan, AB is asking preload means what? I think you covered it mostly, but it's basically the injection of the containers into the OS, right? You want to talk about how that's done?
Yeah, sure. When you go through the process that David and I were just doing, and you download that image is the full OS, but without containers, and it does have an association to the fleet. And what would happen in that case is, you would plug in the device, it goes online, and then it would pull all those big containers down. But when you preload, you're actually putting the containers on the device on the SD card at the time you flash it. So you're flashing it with all those giant containers. And so you could include like that gigantic Open Data Cam container. And then if you tweak Open Data Cam and you don't change the large files, it would just, when you connect that device to the internet, say you ship it across the world and then it connects to the internet, it's only going to pull down the changes, because we have something called Delta updates, where to save bandwidth natively, we just pull down the changes to any pushes that you make to the device.
Now, you
Yeah.
used express shipping and it got there within just a few days, and there's no changes to the application, you haven't made any further commits, that device is going to power on, check in, the supervisor is going to say, these containers are already here, the checksums and hash is correct and valid, away you go. There is no delta in that case. That device goes out into the field ready to run its workload.
Right, and you could pin it to the release that you put on there so that it doesn't, even if it does see a change, that it won't, immediately try to pull that any changes or updates in if you send it out pin. Then you could always unpin it later when you know which updates.
That's helpful, especially, I started to think about exactly this precise project right here of a good 6.5 gigs and of data. And then let's say it's a smart city application or some other, urban traffic planning or whatever the case may be. Rather than ship the device to the destination and then let it download 6 gigs over the air on some cellular link that may or may not be very fast, having those containers preloaded right there from your laptop to the SD card and then sent out, I mean, that's a life. That's a lifesaver in that situation. It could be a big money saver as well. So, yeah, it's a good feature.
Yeah, and pinning the release is helpful too. I pinned this release for this demo so that if by chance somebody deployed a new version, this device while doing the demo doesn't try to update. Not that that would be such a bad thing. It would probably be a pretty fast update, but we don't want that to happen right now.
Alan, is there anything else that you wanted to cover, or are we?
I think we're good. I had put this up before. We had a few takeaways just about what we learned here today, and I know the last one was written by Mark. I'm like, how am I going to read that? Start using 21st century development tools. We're like 20
Mark,
years into this century, Mark.
Yeah, hang on a minute,
I don't think
Mark.
anybody.
What year is he living in? Oh, jeez. I'm going to ping
but
Mark.
I said, leave it in, Mark. I like your having your voice in here. So, I think that I think everybody pretty much got the points that we were making, and this is just a summary of those. And then I'll put my information here again in case anybody would like to reach out with any more questions after the fact. If you're trying to deploy this project, this demo, it'll be up there. So, continue to work with it. If you run into any problems, just let me know.
All right. Well, thank you, Alan. I appreciate it. Thank you, everyone. Appreciate you and your questions. And if you have any further questions, like Alan said, his contact information is right there. And with that, have a great rest of your day, everyone. Bye, guys.